Welcome everyone to another epic firmware update here with our RISC-V, Pico RISC-V, ULX3S, FPGA goodness, oh you name it. And of course, as per the previous videos, being here a perfectionist and such. Also, why do we have drop frames? In the previous examples, getting here everything booted and started, had here fat file system loading here, or full SD support, also took a couple of days. In the meantime, we have here, of course, file access, but previously this was rather limited. You had to know what you're doing. The functions were not very standard conforming, meaning, let me show you this. So as usual with prototyping, I had here very rudimentary functions. Previously, until earlier today, this even had to have here the spaces, because DOS file systems include here spaces, not even a dot, because that is DOS. And also reading right now only a block at a time, meaning 512 bytes, and also not more than one and stuff like that. And I thought it would be nice if we improve a little bit on that, and that's what I did. Let me show you the git diff of firmware.c, and also not color, because I hope you can read diffs in the meantime, otherwise many previous videos. So what I've done here the last hour is made this a little bit, it's not yet fully amazing, but a little bit nicer, basically getting there. I also added a new function, getLine, to read a full line from the console or terminal, serial or local keyboard then later. Basically here maximum length, and yeah, later we're getting into the direction of making this all standard conforming functions. And again, previously the MIDI file was here hard-coded, but now I wanted to read this from the SD card. Basically, instead of having this hard-coded, having here file name and getting getLine here the file name, and then opening the file from the SD card through all the previously established code, because I also not only wanted to play these files, but there's also, as this Roland MT32 was before the time of General MIDI, there is actually some special MIDI file that is patching with system exclusive messages, that it's in memory patching the sound font to be not fully General MIDI compatible, because for that the memory and CPU power and such probably not sufficient, but getting in the direction. And I wanted to try this just for the sake of why not, and having this here more feature complete. This is one of the main reasons, and certainly here you don't want to have your MIDI data in hex dumps here anyway. So this is the main reason, because with that we can also select this other files then. And that's what I wanted to show you. So yeah, this bug we fixed in the previous live stream here, making this a bool as per the previous live stream. And also the system, so trailing white space down. The system exclusive messages, not only did I not had them correct, I also skipped over them. So this was slightly wrong. They are F0, F7 is just the end of the system exclusive. So previously I printed out here, hey, this is MIDI system exclusive, not really doing something with that. And now I have here if one, then hey, run it. Run meaning outputting this here, with the general MIDI data. And so what this allows us is patching, like loading this MT32 general MIDI, special MIDI file with this system exclusive patching stuff, and taking a look how this sounds. Yeah, right, so a couple of more things. So for this, as you see, I wanted to stop having this hard-coded. So what you see here, so until earlier today, this was, as I said, with the spaces here, getting here into the direction of much more amazing firmware, and I want to eventually, not only after prototyping, this is right now fast-paced prototyping, but of course implementing all the standard features and reuse them also in other code. So until earlier today, basically an hour ago, you had to load it like this. Now you can use real file names. And I also changed this. Until earlier, this was a special read function that was totally non-standard conformant. Now we have underscore read. This is basically file system direct. We will later also make this more standard conform. So for all of this to work, like basically having here a file name open with real file names and it's some space garbage, we had to implement this, and this is surprisingly tricky. Oh, well, surprisingly, but basically everything with this C level, previous video C level, or in general low level string formatting stuff, a little bit tricky. So for this I implemented open, a little bit more standard conformance, so that we don't need to have this raw files here all over the place, which if we have this later ext or XFS, BetterFS formatted in our microkernel stuff. So for this, previously I just hard-coded compared here. This is a fat parsing, and yeah, it's not super pretty. It's just like, let's get this, and yeah, this is all from scratch. Like it's not like copy and pasted from somewhere. This is basically all reading the spec and implementing this here with C++ structures and endian swapping. So what is new since today is that we have here some temporary file name, and because we get this here 8.3 formatted here in this directory entry file name, or actually it's like inode, but whatever, it doesn't really matter much. So we get here file name and extension separately in 8.3 with space filled. And to compare this, again, this is surprisingly a little bit inconvenient in C-land. So what is new since today, printf, yeah, also long story short, eventually we should get rid of all this C-ism here, the more advanced we get this. But for today, printf this here, like string print to memory into this temporary file name, maximum 8 character string here, this file name, and then the issue is it is filled with trailing spaces, right? So if this is our empty, or it doesn't really matter if this is, yeah, in our case it's MT32 GM. So this will be 8 filled with spaces. So 1, 2, 3, 4, 5, 6, 7, 8. So like that, I guess. And certainly this doesn't help us much, so we need to remove this. So I wrote here a special rm string trailing, remove string trailing something, trailing white space, trailing space. That's what we need to remove. And this function directly returns, for convenience to fill this here directly, returns the end of string, printing here a dot and the remaining three string characters. And again, this extension might be or will be space filled. So again, remove the string trailing space stuff, print it out for debugging. And this remove string in good old-fashioned direct C coding fashion, from string length string, you see I can do low-level C, not that we usually want this or that it's recommended, but yeah, certainly I can do it. It's always a little bit tricky to get this off by one stuff right, not to have like zero string and so on. So what this is doing is from string length until it's still greater 0. If -1 here offset by 1 from the string length, this is why this is also why it's still greater than 0, not to overrun this buffer, because buffer overruns in C. While this is, or if this is not our trailing comparison character, then break out of there, otherwise --. This is then off by 1, tricky string, bare metal, C string handling. As this is, if this is still the trailing character, then again off by 1, offset starting from 0 there. So this is including the first 0 position, filling this with 0, and when we are done, eventually, so this is greater 0, -1, so this works until the first 0 position, but return here plus whatever loop variable we filled here, so that we continue filling this just as a convenient to directly. Otherwise we would need, if I wouldn't do this here, return the last position, then we couldn't reuse it nicely to continue filling that at the end of the variable. So all of this, we need this eventually anyway. Also what we eventually need this is already prepared to have this UTF-16 handling. So what we should do next is not skip over this, wherever we skip over this here somewhere of some of those here is whatever that was. One of those special cases is UTF-16 handling. Anyway, so what this allows us is opening file names by real name, not with bloody filled spaces. And I also wrote here a new read function because the previous read function was only reading one block. So this is still this one internal fed. Also sometime soon for our firmware, but certainly our more sophisticated microkernel stuff, we need more file systems. So we need some virtual file systems, which not only one hard-coded DOS fed file system, but the new read function, it's not yet perfect. Right now it's still only reading whole blocks, but at least it's reading many of them. So this is direct fed file system inode iterating of clusters. So what we do here now is over the total expected size, reading all of this, looping while total less than count. It's not entirely perfect. Find the bugs if you find any of them. But this, yeah, the bug already, probably nobody. The issue is right now this still needs to be whole blocks. What we would need to do another day is handling less than full blocks, but that is the job of a general purpose file system switch that is reading full blocks from the file system. Right now it's whatever. Yeah, so I changed the MIDI function, command MIDI, to actually open here the file, so it will still play the test notes because it's just some testing here, this handy MIDI support helper functions, but then here printf, so basically MIDI file to load while you type it here on the terminal. It's playing this already to test the MIDI output, and then it is here we have the file system right now, maximum size of 18 because root file system handling. Anyway, later of course we can make this much more sophisticated and even nicer. And if we can open the file, if not file, then could not open. Otherwise, hey, we got a MIDI file, amazing stuff, and read the full thing right now. A maximum, actually, theoretically, we probably should make this size of MIDI file. I just changed this for some reason. Yeah, right now it's 32K or something. That is enough for the MIDI files right now. When we loaded this, turn the notes off just in case and play the MIDI file. What this allows us, previously we had this hard-coded there, the one hex dumped MIDI file, and now we can actually freaking load this from the SD card. That is, as you see, all the changes here, as I explained here, quickly walked over this. So let's, with the latest, let's compile. Actually, we probably didn't save this. Let's see if this still compiles. Also probably live here on this channel. Maybe introducing some last minute bug here, and maybe I show you the difference in, as we probably have the time. So that's basically the quick rush through of how to bootstrap a completely new firmware, whether be it for your Commander X C16 or X16 or whatever that was, or our RX32 RISC-V stuff, how you step by step first do some prints, then some file system, SD card, memory enablement, audio, video, and now probably sooner or later have everything working. Probably next we should really attach some keyboard. Due to the previous video, also, by the way, I hear my own echo, that is super annoying. Monitor off. I also sometime soon need to actually fix some bug. Right now the SD card has some timing glitch. Earlier it was working. I think it has to do with the very high clock frequency. See, now we have here monkey TGA. I probably should output this on the HDMI. So yeah, I need to run this a couple of times for initialization. but they also need to fix this timing, SD initialization timing. It probably this is somehow like too high clock frequency or whatever. The SD card doesn't like it the most, but whatever. Once it's initialized, it's working reliably as far as I can see, so it should just be some tiny little initialization glitch. So as a reminder, I only play this passport first without the MIDI remapping. So now we have here, that is this node, and now we have MIDI file to play that is new. Also can give you this sharper. So that would be passport mid. And yes, theoretically, we should also uppercase this automatically. Right now it needs to rely on the human to it's basically case sensitive, just that FET should not really be case sensitive. So this will play this. How actually did I what was it, this or this one of also not this, yeah, channel 1 to 8. So this will play it natively with the non-general MIDI stuff, and it doesn't sound amazing, but also to see you how far we have show you how far we have come with implementing the basically full set of all kind of multi-track MIDI stuff for your games, for your demos and other OS stuff running at home. So first, natively, not sounding amazing, I probably stop it after 10 seconds or so, and then we redo this with loading the system exclusive stuff of patching this linear, arithmetic or whatever that was there on the fly for more general purpose, general MIDI stuff. So this comes when you plug out your FPGA USB to reset it. So as you see, that didn't sound amazing. It basically also makes it sound amazing. So this is how it sounded previously. Also we can refresh this in the meantime because I'm running this out of the bit stream out of memory. So tiny little refreshing time here. And yeah, so this is how it sounds originally. Also just checked, yeah, it's LA stands for linear arithmetic here. So Roland MT32 multi-timbre sound module here, 1987. Sounds pretty amazing for that time. 15-bit, original version, 15-bit linear arithmetic. Actually, fun fact, an Intel CPU in there. And yeah, what polyphony did it had? Anyway, yeah, 32K and stereo. So for 1987, pretty amazing. Theoretically 16-bit, also tiny implementation. Glitched there, 15-bit effectively. DA conversion at 32 kilohertz stereo. And so now let's repeat this. This is patching. So that means, can we also maybe zoom? Let's see. Probably didn't. Yeah, so here's a terminal. So let's first initialize. As you see, this SD card needs a couple of times until the timing initialization stuff. So then we do this audio stuff for MT32 general MIDI.MIDI. Not a MIDI file. Thank you very much. MT32 general MIDI.MIDI. Why is this MTGM? Was it just MT? Maybe. MTGM.mid. Let's hope it's that. Maybe it's that. Hopefully. As you see there, this is also system exclusive. So what this is doing, as far as I understand it, it's patching all those instrument banks there in memory. Again, so this is an Intel CPU 8085-ish or something. And so it's patching using the system exclusive method. This basic system MIDI system exclusive is basically exclusive for this device. If you send there some random garbage, it will do random garbage. And with this allows to program stuff, patch stuff, so a lot of digital music instruments implement custom system exclusive memory patching stuff. So this should have patched this 1987 before general MIDI, Roland MT32 MIDI to more somewhat general MIDI. And when we now do this sorry, so much to the test tone, let's mute this for a second. So this test tone already sounds differently, so that worked. And this is not implemented here, by the way, is only non-implemented dynamic string length. And if we now already switch over to that and now do passport.midi, it will sound totally amazing because pretty patch for general MIDI, as good as you can get this old-fashioned device from 1987. Let's unmute the audio channel and enjoy this in full glory. Yeah, and I would say that certainly sounds pretty amazing for a 1987 device, here controlled from our RISC-V FPGA. And I just checked here that this, by the way, as documented here on Wikipedia, is an Intel 1895 microcontroller. Also, yeah, irony of modern RISC-V, but yeah, a couple of decades later. But of course, by the way, if you wanted to, you could theoretically, probably someone has done it already, MT32 completely in an FPGA, but that's, yeah, we could do this, but we rather need those resources for graphic sound, audio, and all the other fun stuff. But so inside there, in this Roland from 1987, a Intel MCS96 family of microcontrollers, also referred to as a 8XC 190C family, most popular MCU in the family, commonly used in hard disk drives, modems, printers, pattern recognition, motor control, and yeah, MIDI devices from 1987. Just to iterate, also don't need that. How far have we come? Of course, mostly I do this here for the RISC-V system enablement, and yeah, we didn't really need MIDI, but it was a fun stuff with all the MIDI and vintage retro stuff out there on YouTube. I thought it's a nice addition, interesting low-hanging fruit of here. Of course, we can just instantiate here another serial UART and connect it there and have the stuff going, running at 32K baud of something of that sort. Certainly in terms of our firmware, huge enablement. So to reiterate what is coming together here for this to work, we have certainly in the background running VGA for video output. We have our own FM synthesis or tiny little square wave FM synthesis here also running theoretically, as well as direct stream digital. So for frequency modulated game music, for direct stream digital 16-bit stereo deck output, all the previous videos. Additionally, we interface the SD card here, so this stuff not coming from hard-coded hex dumps, but from the SD card, which, tiny little initialization glitch, but otherwise it works. Also on top we implemented FAT file system reading, because otherwise you would have only raw blocks. Certainly raw blocks not as amazing as a FAT file system, so iterating, reading this FAT code on the SD card from the RISC-V firmware, block for block, cluster for cluster, matching the file names, jumping from one cluster to another, reading the stuff to memory, then Targa file parsing for loading the Monkey Island, previous video, matching Monkey Island's graphic here to the VGA implementation on our FPGA, or in latest this week's MIDI file playback, including all single multi-track, timing this. Right now, brute force delay, busy loop timing this. Of course, next. What is next? Next would be high resolution timer, interrupt driven, not to waste all this precious RISC-V cycles that we need for game logic, certainly. And last but not least, of course, still, yes, I've still not attached a keyboard to that. So certainly for the icebreaker, but also this PS2, maybe even for the RX32 big system here on the ULX3S USB, theoretically, probably, most likely, some coming months. But there you see documenting here what is needed to make this a usefully working system, on top of just having some bit pattern output. Of course, having some software that plays along with the hardware, implementing software functionality. You cannot do everything in hardware. Of course, it's fun and nice to do all in hardware, but at the end, the software is, of course, as you all know, the easily modifiable stuff. Hardware, you cannot just poke there with some electron microscope and move some logic gates around. So our flexible software that you can download there for you to play along at home, share games software, as we got used for the last 40 years or plus, even longer, to load games here on the system, game software, operating systems, and making the hardware tick, programming the hardware, reading files, playing back video and audio, here documenting the journey of whole system enablement. I hope you enjoyed this. For me, even as you see, certainly I do what I have fun here with. All the stuff that I didn't have as a kid there, because it was bloody freaking expensive. I think the recommended sales price $6.99 or something of that sort, which actually we could fun check. But I basically, when I grew up, Roland MT32, I probably barely heard about this. Internet certainly wasn't a thing, and I basically knew nobody who had that, and I'm not even sure when we knew we are introductory price of $695. Also, I could switch to that and not making this stuff up. And actually, I slightly wonder what would this even be in German Deutschmark. Maybe this would have even been 1,500 Deutschmark actually, so long time ago. What is, can Google $695 inflation? So that would be in today's dollar by year. That would be why does it say this is also not the right year? Darn it, 1987. Oh, come on. Let's fact check that. hello, can we calculate that? So that would be inflation adjusted. Yeah, such a device, just to put this into perspective, because yeah, $695 in 1997 certainly was something else worth, and that is $1,600 in today's greenbacks. And I actually, what would this be in German, Deutsch mark? How does it have here? Is somewhere for those Europeans playing along at home? Can this swap currencies of, is this US? It is US, so 695. 695, just to put this, yeah, 1,200 something Deutschmark in plus inflation, so, and in euro, you get the idea. But yeah, certainly totally fun. How many years later? 30 years later. And it still sounds amazing, right? Especially the patched version for, well, the original version, of course, for the Sierra and what else was it? Lucasfilm games. Sounded amazing, but the other modern passport, the other more modern MIDI songs, of course, sound way more fantastic with this patched version. And yeah, certainly I hope you enjoyed it as much as I did. This fun little extra excursion here of MIDI and having fun with it a couple of decades later and implementing all the fun stuff. Next, certainly, as I said it again, the last things missing for higher efficiency, interrupts, and certainly then keyboard, as I mentioned, but otherwise, yeah, fixing a little bit initialization glitches. Also, last but not least, we implemented SD memory, previous videos there, and I wanted to load, I have the feeling I broke it, unfortunately. We could actually, so I probably have to debug memory stuff. Again, not really sure what broke this. Probably it will error out, because I noticed this not using SD memory, 64. I hope I didn't electrocute it here. Yeah, failed at index. I need to check what I broke there. Apparently something. It could be just Jose's next PNR synthesis stuff. This is also probably, I should have done some boot up memory test. Actually, fun fact, I probably think, does it do a memory test or did I patch this away? Actually, I need to check. But yeah, I hope only the synthesis stuff broke a little bit. I also saw the Jose's next PNR authors on Twitter published some bug fix for differential I/O pairs there just today. So probably I should also update the Jose's next PNR. Maybe it's only next PNR in T2 and in general. And yeah, otherwise I should actually debug what I broke in terms of, yeah, so much too. I didn't really touch it much, but now SD memory is broken. So there's hardware is different and hardware is difficult and different. But yeah, next I can debug the SD memory again, which I've done already 3 times. So most likely only timing thing. Theoretically, maybe if we resynthesize this, Jose's or next PNR might already give us a clue actually of maybe some timing stuff, because I'm running this here quite a bit on the timing edge. This was previously handpicked. When we come up, this is handpicked right now running at 41 megahertz. Maybe we just overdrive it there a little bit so much to handpicking your frequency. But anyway, yeah, as usually, I hope you enjoyed this. I hope you see that I basically do this here mostly also for what I have fun with here as a hobby, and I hope it is fun for you and you learn something. And yeah, next we can actually commit this. Most of this stuff is already upstream. Basically the firmware, as you see, the firmware here, all the stuff earlier from today, including all the MIDI stuff, is already upstream. At least I think. I also need to check here some trailing new lines, not new lines, trailing white space. Unfortunately, somehow not really sure. Usually I'm relatively good with it. Oh, wait a second, there was just one. But when you copy and paste with modern editors. Probably I should configure Emacs to Pretty Princess in solid red, just like that. But yeah, this stuff is getting more complete. You see, it's so much nicer to use it like that. Certainly you all agree. Leave me in the comments below what you like and dislike, what you learned or find is trivial or not trivial, or what I should also here, tiny little typo probably from VI is usually the VI or Emacs confirming something. Anyway, also there is some more for I equals, that is space behind there. Oops, what did I not? Wait a second, what? Why does this not match something? Or is it patching this away? Anyway, no, it's not. Why did it not? This is around line 13, 15. What was it for? Somewhere. Probably. Ah, here it is. Not really sure why. I didn't match that. Anyway. Yeah, probably soon, but this takes so much time, basically, which also, yeah, the camera view is not the most amazing, I know, but basically next is also perfecting the Verilog code setup so that we can generate. Right now it's a little bit YOLO'd of, I've broken Icebreaker right now, and some of the ULX3S, yeah, the VGA, I need to make the Verilog code a little bit nicer for instantiating the video core, so that it's a tiny instance on the Icebreaker and a larger instance with more memory and more features on the ULX3S. But yeah, you see, the problem is, as per usual, the 90%, 10% rule. 90, basically the last 10% take again 90% of the time, because getting it to work somewhat, but is yeah, 90% of the code, 10% of the time, or the other way around, because cleaning it up, like getting it to work is one thing, but cleaning it up so that we can have everything upstream is the other thing, and that for sure again takes 90% of the time again. Also debugging it then, as you see, I just broke the memory controller, and I can also disappear. Just broke the SD memory controller, and yeah, basically just moving all the code around, parameters around. But yeah, that is for the next days or weeks, and certainly when you ordered ULX3S, which is there on crowd supply, I hope it's not yet sold out. Maybe you can still grab some ULX3S there on crowd supply, shipping later this year or something, I heard. Actually, we probably could check this shortly if it's already completely closed, or if this is still for you to ULX3S. But that's basically it, what I had today. I hope you enjoyed this update. And crowd supply, where is it? Get in touch, get it somewhere of crowd supply. Does it? Here is funded. Is it also still to pre-order? Not really sure, but I hope it is for you to play along at home. Hey, 3 days left, so apparently, yeah. I hope with the earthquake there and the virus, it's still going strong there. Certainly wish them all the best. Anyway, so apparently you have still three more days to go, in case you interested in this pretty epic, large and such. This version, there are different versions. This is the 85,000 85K LUT version. Yeah, so there is an entry-level version 45K and an 85K and a lot more, and in what ECP12F board with lattice. What to large project deploy? Ah, right, this is a 10 pack. I was just wondering about this. Anyway, so yeah, this is the crowdfunding. Super amazing board. It's not a paid advertisement. I got it not directly from them, by the way. I got it from Symbiotic EDA there in Vienna. Also amazing team there of all the open source. The design tools, so not a paid advertisement in any way, but certainly highly recommended. Symbolic EDA as well as this ULX3S, also open source, open hardware project. Totally amazing stuff, highly recommended. And yeah, for you to play along at home, I certainly need to clean this up again. 90-10, 90% code done, but 90% work of cleaning all the stuff up still left. I hope you enjoyed this. Theoretically, I could play this again. Not really sure did I reset this, but actually, you know what? Why not? Let's. Did I plug it out? Not really sure. Screen. Did I? I have the feeling I plugged it out. Yeah, I think I plugged it out, or there's something else broken. ULX3S, because I didn't flash it on the permanent bitstream, because loading this bitstream like this with I still use these old-fashioned tools because they work for me. With this UJ proc or something, flashing into EEPROM is so much slower. I mean, obviously, right, I just loaded, so yeah, it has 100,000 write cycles allegedly, but for write cycles, although 100,000 certainly enough for everyone, but why not save some write cycles? And it's much faster anyway, so loading this into the memory here directly. And yeah, one more time, because why not? Initializing the SD card, because it's, yeah, also yeah, need to fix this eventually. And then audio, GM, what was it? GM, no, this was one, darn, MT, GM, I don't have backspace, so this will not work anyway. This will have the backspaces, so much to, yeah, also the firmware should have command line editing. This is MT, GM, MIDI. Yep, that works. It has intentionally timing deltas in there. I hope, yeah, this probably is still on. See, this is receiving there. This file has timing deltas in there, as you see. Otherwise, it would be quite instant. I guess Roland has designed the special MIDI files so that the timing delta might be so that the Intel microcontroller there has the time to copy it to memory or something. I'm not sure if it works if you edit the timing away to load faster, no idea. And then, last but not least, the famous passport MIDI. And that's it for today. And don't forget to like and subscribe. And I hope to see you soon for the next videos, tinkering, coding, live streams to come. And in case you're wondering, of course, this system exclusive MIDI message patching is runtime only. So as soon as you power cycle this, you lose this patching. So each time you would use it for professionally, or semi-professionally music stuff, you would need to re-patch this. So yeah, or if you have a game, like you write a new game demo stuff, you always need to run this if you want it to the MT32 anyway, or a user on system boot up or something like that sort. But that's it for today.